Hey class, how's it going? I thought it would be a good idea for me to just run through an example problem of how to calculate the derivative of a function at a particular number. So we're going to start off with right now just hopefully reminding you all what the notation is for the derivative. So if we have a function f of a or f of x, if we derivative of the function f, we would write it as f prime. And since I'm finding it at a, I'm looking for the derivative of the function f of x at a, so f of a. Now the function that we're finding the derivative of here is x squared minus 8x plus 9. And from the definition 4, we can say that the limit as h approaches 0 of f of a plus h minus f of a, all divided by h, is going to produce for us the derivative of the function f of x at a. So to calculate this, we can say that the limit as h approaches 0 is going to equal, now first, in order for me to calculate f of a plus h, I need to take a plus h and plug it in for x in every place that it exists in the original function. So by doing this, I probably should have given myself a little bit more room here to write it, okay? But by doing this, we're going to have brackets, and then in parentheses, in place of x, we're going to have a plus h all squared minus 8 times, instead of x, a plus h plus 9. Close the bracket, okay, and now this is the second part of our definition, so now minus f of a. So all f of a is instead of f of x, we're now going to plug in a in for every place we see x. So it's going to be a squared, we'll put it in brackets to separate it, because that's important because this negative sign needs to be distributed, minus 8a plus 9. Okay. Now all divided by whatever h is. And so we don't know what h is, so we just simply write h. Okay? Now, as we continue to move through this, notice we're approaching 0. So I can't plug 0 in here for h, because if I did, it would be undefined, and essentially this function has an asymptote, which is why it would represent a function that would be undefined here, right, at 0. So I'm just going to continue to simplify this, and you'll notice that the a will become eliminated shortly as we go through it. So I'm going to give myself a little bit more room here. We have the limit as h approaches 0, okay? And now to simplify this, I need to do a plus h times a plus h. And we should be able to do this with our eyes closed at this point, but a squared plus 2ah plus h squared. Is this simplified? Now minus, we're going to distribute the 8, so it's going to be 8a, and then we also have to make sure that negative continues to carry, minus 8h plus 9. And then all we're going to do here is just distribute the negative all the way through, so minus a squared plus 8a minus 9. Okay, so that's my numerator. Denominator is h. Second part here, now I'm just going to simplify it all the way through. And when I simplify it all the way through, the a squareds become eliminated, the 8a's become eliminated, and I think I could just add like terms at this point here, if there are any like terms. So as I go through and add them, I'm going to have the the 9's also become eliminated as well. So all that's left here is going to be the limit as h approaches 0 of 2ah plus h squared minus 8h. And one thing that's really cool that we notice here is that there is, and my son's walking in the room as I complete this problem, but there is an h in each of these terms, and with the h in the denominator, we can divide that h out with each term. So basically, we have the limit as h approaches 0 of 2a plus h minus 8. And because h does in fact, if we were to plug the 0 in here, h would equal 0. And then at that point, it would allow us this to equal 2a minus 8. Okay, so that is our derivative at the number a. Thanks.